Now I will talk about introduction of vector. Vector is defined as an object containing both magnitude and direction. Then vector describe the movement of an object from one point to another point. Vector is very useful in the simplification process of three-dimension geometry. Vector is defined as a mathematical structure. It has many applications in the field of physics and geometry. Now I will talk about history of vector. Today, analysis of vector is primarily based on geometry, but before the 19th century, their quantities were relatively unknown, and where they were considered, they were explained algebraically. Second, a vector is used as mathematics, physics, and computer science. It's a quality with two parts in magnitude and direction. First, in mathematics, the Irish mathematician William Roman Hamilton introduced the concept of quaternion, a four-dimensional number system that provides a foundation for vector algebra. This laid the groundwork for the development of vector calculus and the algebra representation of vector we use today. Then the second story in physics, vector has important use in this field. Sir Isaac Newton employed vector to explain force movement and celestial mechanics in this law of motion and theory of universal gravitation in the 17th century. The rule opened the path for classical mechanics and word assertion for comprehending the dynamic of moving things. Then in computer science, the growth of computer science and its application were significantly influenced by vectors. Computers start employing binary digits bits to represent process data in the middle of the 20th century, as they were used to represent array matrix and other data structure in computer programming. Vector come to be regarded as fundamental ideas.
The first application of vector is application in softball. A vector is mathematical tools used to represent physical quantities that require both a magnitude and direction. To describe such physical quantities including things like positions, velocities and forces. The velocity of softball is a vector quantity. The magnitude of the vector represents the speed of pitch and the direction of the ball. Find the magnitude of vector for the point 2/3, square root 3 and 2. To find the magnitude of these 3 points, you use the formula of V equals to square root A squared plus B squared plus C squared. In this example, A equals to 2/3, B equals to square root 3 and C equals to 2. So this is the solution for the question. Okay, back to the application of vector in softball. Vector can be used in softball to measure hit as well as pitches. When a ball is hit to the outfield, it has a direction, speed and distance. The speed and direction of pitches can be measured using a vector. This is the problem that related to the application of vector in softball. A batter A is at a point 0, 0. He hit the baseball to the left fielder at point -4 and 6. What is the magnitude and the direction of the ball? Here is the solution. Batter A is at point 0, 0. He hit the ball to the left fielder at point -4, 6. To calculate the magnitude and direction of the ball, we can use a vector mathematics. Let's determine the displacement of vector, which is the vector that point from the batter A to the left fielder. The displacement vector can be calculated by subtracting the initial position vector, which is 0, 0, from the final position vector, which is -4, 6. For the displacement vector, -4 will subtract with 0 and 6 will subtract with 0. So the new point will get -4, 6. Magnitude of the displacement vector can be found using the Pythagoras theorem. So just put the new point into the formula. Therefore, the magnitude of the ball is 7.21 unit.
Moving on to the second application of vector is AI and enemy detection. What is AI and enemy detection? It is an AI control characters or enemies that need to detect the presence of other players in the game world. This detection often involves determining if the player is within the line of sight of the AI character. In this application, the dot product is used to determine the line of sight. The dot product, or known as color product, is used to determine how closely two vectors align. It also can be used to compare the two vectors and positioning one or both of them. Dot product is calculated by multiplying the corresponding components of the vector and summing them up. Dot product gives a measurement of the degree to which two vectors are pointing in the same direction. Dot product can have values in the range -1 to 1. When the values of the dot product is near to 1, the two vectors are pointing in the exact same direction, which means the player is in front of the AI character. When the player is outside the AI character's line of sight, the value of the dot product is near to -1 and near to 0, which are they pointing in the opposite direction or they are at 90-degree angle. Moving on to the application, let us say that the AI forward vector and the vector to the players are as shown. Now, we need to normalize both of them. Moving on to the application, let us say that the AI forward vector and the vector to the player are as shown. Now, we need to normalize both vector to unit length. Now, we calculate the dot product. In this example, the resulting dot product is 0.2592. The value is near to 0 that indicates the player is not within the field of view of the AI character. Let's modify the example. Now, let's consider the vector to the player that is aligned with the AI forward vector, indicating that the player is indirectly in front of the AI character with the vectors as shown. The resulting dot product after the calculation is 1.142. Since the value is near to 1, this concludes that the player is within the field of view of the AI character. This is the summary of the two examples shown here.
So we go to the next application that we choose. The third application that we choose is relative velocity between two bodies moving in the same direction. Now we go to the velocity vectors. Velocity vector is when two objects P and Q are moving with different velocity. Then the velocity of objects P with respect to the objects Q is called the relative velocity. Now we consider two objects moving with uniform velocity of v1 and v2 respectively along the parallel tracks in the same direction. For the formula that we use to find the velocity vector is we just minus the velocity of two objects, like example velocity of objects A minus by velocity of objects B. Now we go to the example of these applications. As we can see at the figure, the red motorcycle moving with speeds 30 km per hour. Meanwhile, the blue motorcycle moving with speeds 15 km per hour. Since the motorcycle move in the same direction, the relative velocity of motorcycle A with respect to motorcycle B is velocity AB equal velocity A minus by velocity B. So the answer for the example is 30 minus by 15 and equal by 15 km per hour.
For the next example is boat cross river. Relative velocity. When a boat is traveling through the water, now as fast it is moving in relation to the water is crucial for navigation. By taking into account vector, this velocity may be determined. The boat vector of velocity in relation to the water is equal to the vector sum of its own speed through the water, often referred to as boat speed, and the speed of the water currents. The result vector, which is reflect the boat real velocity, is used to calculate the boat position, the amount of time it will take to get there, and any necessary cost change.
Okay,
What is relative velocity? The speed of a boat relative to a fixed observed or reference frame is referred to as its relative velocity. It displays the motion of the boat as seen from fixed point or reference, either the land or the area surrounding a water. Sailor can determine the boat's actual speed and direction in respect to the environment by calculating the relative buoyancy. Problems. The current in the river, which is running at the speed of 5 meters per second and at an angle of 30 degrees north of it, is following at the speed of 10 meters per second greater is when the boat crosses it. Determine the importance of the boat motion by calculating the cross product of the boat velocity vector and the river velocity vector. As you can see, I already put in the slide the equation of a cross product. Solution. To calculate the cross product, we need to determine the components of velocity vector and perform the cross product calculation, giving both velocity, or we can write as VB, is equal 10 meter per second with S. Next is river current velocity, or we can write as VC, is equal 5 meter per second and angle of 30 degrees north of S.